Let's take a look at some theorems related to similarity. First, if we have a right triangle and you draw the altitude from the hypotenuse, the length of that altitude is the mean proportional, or the geometric mean, between the two segments formed on the hypotenuse. So what that means is CD, the altitude, is the geometric mean of the two segments that it creates from the hypotenuse, AD and DB. AD and DB within segment CD. So in this example, we have the right triangle and the altitude to the hypotenuse is drawn. The entire length of the hypotenuse is 8, AD is 5, find the length of the altitude. So if AD is 5, the whole thing is 8, that means DB is 3, and the altitude CD is the mean proportional, or the geometric mean, of the two lengths that it cuts the hypotenuse into. So that means it's the square root of 5 times 3. So we can just say it's the square root of 15. Next, we'll talk about the side-splitting theorem. If you have a parallel line, or a line that's parallel to the base going through the center of a triangle, it will form similar triangles. That's because of corresponding angles. But you can take that one step further and just say that the sides are split into proportional segments. So BD to DA equals BE to EC. The sides are split proportionally. So in our example down here, we do have the two sides are parallel, and we're also told D is a midpoint, so that means it cuts it in half on this side. Show that E is a midpoint. Well, just by using the side-splitting theorem, we could show, or we could write that BD to DA is proportional to BE to EC. But then by saying that BD and DA are the same length, because it was a midpoint, that becomes 1 to 1, which means BE has to equal EC, you could by cross multiplying, and therefore E is a midpoint. Next we have the mid-segment theorem. It says that a mid-segment, which connects the two midpoints, is parallel to the third side. So they would be parallel, and it's exactly half its length. Well, parallel comes about basically because of our previous theorem we just talked about. The sides are split evenly, so they are proportional, so the top and bottom are parallel. Also, the triangles are similar, and the big one would be, all the sides would be twice as much as the small one, because D and E are the midpoints. And the last theorem is the mid-quad theorem, which says that if you have all of the midpoints of any quadrilateral and you connect the midpoints, by connecting the midpoints you are drawing a parallelogram, so the opposite sides will be parallel.